Hello everybody and welcome to our lesson on section 15G, derivatives of trigonometric functions. So here are the rules for differentiating trigonometric functions. If we have a sine function, then the derivative is cosine x. And if we have a cosine function, the derivative is negative sine x. And they seem kind of circular, and that's because they are periodic functions. I would suggest that you check out this video. I'll put a link in our Google Classroom documents. Let's apply those rules now. So we've got a bunch of different trig derivatives that we're going to work through. Okay, and just so that we're not so overwhelmed, let's take a look at part A. So the derivative of sine of 2x, we're going to use the chain rule. So we're going to do the derivative of the outside part, which is sine, times the derivative of the inside part, which is the 2x. The derivative of the sine 2x part is cosine of 2x, and the derivative of 2x is 2, so we get 2 cosine 2x. For B, we're going to apply some of those rules that we learned before, the addition rule. So for sine x plus cosine x, the derivative of sine x is cosine x, plus we're going to take the derivative of cosine x, which is negative sine x, and we're going to watch our signs. Okay, a plus and a negative together make a minus sign. Okay, and just watch out, don't mix this up with our double angle identity. Okay, we do have a couple of trig identities that we'll review, that we've reviewed earlier and you may use to help you, but right now this is just a single, these are just linear terms, or not linear, but not squared. Okay, moving right along, here's some more examples. So for this one, the derivative of cos of 3x minus sine x, we're going to need to use chain rule here and our difference rule between those two functions. So we're going to take the derivative of cos 3x. Remember that this is the outside function is cos, and the inside function is the 3x. So we're going to do the derivative of cosine is negative sine of 3x, and then the derivative of the inside part is 3. And we're going to take the derivative of sine x and subtract it. So we end up with negative 3 sine 3x minus cosine x. Now, this example here, it's a little hard to see. That's f of x equals x times tan x. You can just delete that. Now, x times tan x would be using the product rule. We have one function times another function. Also, we don't have a rule for the derivative of tan x yet. We will soon, but if we don't have the rule, we're going to use our definition of tan x as sine x over cosine x. And then we're going to use the product rule and the quotient rule, because we have to think about the product of x times sine of x over cosine x, but to take the derivative of this part, we're going to need to use the quotient rule. So first we take the derivative of x times sine x over cosine x as is, plus the derivative of sine x over cosine x times times x as is. And so in here, I'm going to have to use the quotient rule again. So I've said what I'm going to do. Now I'm going to actually do it. I'm going to take the derivative of x, which is 1, times sine x over cosine x, plus the derivative of sine x over cosine x is cosine x times cosine x minus the derivative of cosine x, which is negative sine x, times the numerator, which is sine x, all over the denominator squared. And that's being multiplied by that original x. So I end up with sine x over cosine x plus x times cos squared x plus sine squared x, and that equals 1. That's our Pythagorean identity. Okay, so I can replace that with a 1, and I can simplify a little bit. So I can multiply the x by the numerator here. I could go further, but I'm going to stop there. I'm going to continue the examples in our next video.